Well, to me the skirt here looks better. I have raised the Z probe height up. This is ABS. I am printing, this is the head part of the Vernier gauge box. This is a deeper version because the other versions, although the Vernier gauge sort of fitted, was a bit shallow, so this is a deeper version, pretty much the same print, a few other modifications. I believe this is about a 3-hour print. I like the look of the skirt on here. I generally, well, all the time I print skirts on my models to get the filament flowing, and I'll just give a bit of a check. It'll be interesting to see if there's any curling on this. I did get a little bit of curling on the previous prints in ABS. 100 on the heat bed here. That's a PEI sheet on top of that, like an aluminium sheet with a heat pad under it. 235 on the nozzle, 20% infill. It's an E3D version 6 clone with a 0.4 nozzle on there, using a ring fan shroud thing, so the air blows through that part there, like a channel, and then down onto the part through a ring. That's a BL touch there, that's for doing the auto leveling, forming, etc. Very good. Work on almost any surface. I'm going to pause the video just now. Well, just reiterate, 235 on the nozzle, 100 degrees on the heat bed. The fan is set to come on at about 0.6 layer height, and that's set to go up 40% using this fan here. So the air blows along here and down onto the part through a slot in the bottom that almost totally circulates the E3D version 6 hot in there. Okay, let's pause the video, come back in about an hour or so, I think. Well, it's 1 hour 42 minutes into this print. I think it's going quite well. It's hard for me to know whether it's lifting and curling in the corners because there is a design curve on the edges of this print. We can see the sort of layout of the head part for this Vernier gauge, and there is a like a circle there that's for a button battery. I made it big enough to take a bigger one than what mine uses, my Vernier gauge uses, bigger diameter, so if you have a bigger battery it should be okay. This should be okay for a dial gauge. I have put a part on here for the dial. I hope that's in the right position. I don't really have a dial gauge and some might be in slightly different positions, so I have tried to allow for that. You can see the infill here, it's set to 20%. So although this model is quite a bit deeper, it's about 17mm deep actually, because of the infill it won't use, well, massive amount of plastic. 20% on the infill there. Looking at the display, it's about a quarter of the way through. Bingo 1 and 3/4 hours. 1 and 3/4 hours. I'm going to pause the camera again just now. I'll come back in an hour or two. Two hours 41 minutes. You can really see the shapes coming out now for the head of the Vernier gauge, and like an opening here almost for, well, a button battery. As I say, I've made this, designed it to fit a bigger diameter button battery in case your unit uses a bigger diameter button cell. Mine uses quite a smallish diameter button cell. That loop up there, that sort of curve up there is for the dial gauge if you have one. So this should fit a mechanical or a digital Vernier gauge. You can see it's a lot deeper than the previous prints I did. Let's see what height am I at. It's at 13.5 and it should be going to about 17mm high. Looking at the bar graph, it's a good 3/4 of the way through. Move angles a bit. Can't really notice any curving on this model. As I say, I did raise the Z probe up again, and the skirt does look better for this model than some of my previous prints. This is ABS 100 on the heat bed there, onto a PEI sheet, 235 on the nozzle. There's a fan blowing down onto the part that's set at 30% in my case. This is quite a powerful fan unit. Okay, I'm going to pause the video again and I'll come back in about, well, 3/4 of an hour or so I think, and we'll see how it's progressing then. So it's 2 hours 46 minutes actually into this print. Layer height is 14.1. We can see that on the display. I'll just show you the display before I stop this video. I'll turn off this light. So here's the display, 2 hours 46 minutes. This is the layer height here, 14.3 now. So we've got X and Y which are constantly moving. We've got the bed temperature. Sorry, I'm having problems. I'm having problems seeing this, but that is 100 there. This is 235. Got the target on the top and like the actual temperature reading below that. 30% on the fan speed. Hopefully you can see that. I can't see that in my camera display very well at all at the moment. Okay. Right, I'm going to pause the camera now. Well, it's just finishing off now. The nozzle's just going up. That was 3 hours 12 minutes. I'll play a tune on my sort of LCD controller amps G-code. Looks okay. The bed's still warm, it's on 42. 3 hours 12 minutes. I'm going to take a risk. It's just a bit over what we'll term as lukewarm. There is a bit of a curve on the edges of this. That's in the design. Comes off quite well there. My camera I'm using at the moment has got a really bad display on it, so it's hard to make out. There might be a tiny, very small bit of lifting over this corner. Quite lightweight, but as I say, it's 20% infill. So the gauge basically goes like this. Part for a dial, and this section here is for a button cell. This is just a demonstration button cell there, in a way a bigger one. So hopefully you can press on that, see it almost, the idea here is to press on this side and you can grab hold of it. That's why it's got like a step down here. But the button cell in my gauge is a lot smaller than that. Actually, let's try this button cell. So there's my button cell there, and actually that fits in the smaller diameter. This will, obviously the will rattle about, possibly pour a bit of stuff in there to stop them rattling. Is that easy to get out? Well, not too bad, I think. Yeah. So now it's the main body part. Let's see how this does for depth. I think it might be, oh, that's just touching this display here. So try to show you that. If I put that ruler right on the edge, it is just almost touching that display. It's not knocking it. It does like that because the the weight of the gauge on the other side is tilted up. That's just about ideal, I think. And you can see that the jaws are open slightly. There is a bit of leeway there, I think. Have the doors open slightly, a bit of space here for like a thumb thing on. Mine does not have a thumb thing, however. A bit of space here for locking, if you have like a locking thing. So there's a gap there, and gaps on that side for any locking nuts or whatever you might have. Some Vernier gauges have locking things on. Mine is a dead cheap one. Yeah, that's good. That now it's the main body part, which should match up to the same thickness as this one. The skirt came off in one piece quite easily, so raising that up seems to have been a major help.